Welcome. In this problem, we're going to look at a stoichiometry problem involving gases. And so if you think about stoichiometry, it's going to be any calculation involving a chemical reaction. And things that we have done so far to find moles is we can use molarity to find moles of a reactant or product. We can use the mass and molar mass to find moles of a reactant or product. Or if a gas is involved in the reaction, we can use PV equals nRT to find the moles of a reactant or product. So this example right here, we have a reaction involving a gas. We've got silver oxide decomposing to form solid silver and oxygen gas. And we complete a reaction and we have a bunch of data here. So it's helpful to kind of write down what we know. So we collected some oxygen gas. That's our product. We know the volume of it is 4.58 liters. It was collected at a pressure of 745 millimeters mercury, which is the same as a torr. The temperature is 308 Kelvin. That's nice. It's already in Kelvin for us. And it looks like we've got a P, a V, and a T, and we know PV equals nRT. And so it looks like we should be able to have enough information to rearrange and solve for N. Okay, so this should be able to tell us moles of oxygen. So we know the pressure is, again, 745 torr. The volume is 4.58 liters. The R value, I want to make sure I choose the appropriate R value. I'm going to use 62.36 because that's liters, torrs, Kelvin, mole. So it matches my pressure reading in torr. My volume's in liters. My temperature has to be in Kelvin, so Kelvin cancels out too. So I plug this all in and I get 0.178 moles of O2. So far this just looks like a ideal gas law problem. Now let's get into the stoichiometry piece of it. We know moles of oxygen, but what we want to find is how many grams of silver oxide decomposed. So my first step in any stoich problem is found moles. I've done that. Now my next step is going to be use my mole ratio. So I'm going to convert from moles of oxygen to moles of my reactant, silver oxide. So it looks like from this equation, for every 1 oxygen, we have used up 2 silver oxides. The question asks for grams silver oxide, so I'm going to do one more step. I'm going to convert from moles silver oxide to grams silver oxide. And whenever I go from moles to grams or grams to moles, I'm going to look at the periodic table, and it tells me, when I add up all these masses, that tells me that 1 mole of silver oxide weighs 231.74. That's kind of heavy. Okay, so if I go through and check my units, moles oxygen cancels out, moles silver oxide cancels out. I'm left with an answer that has units of grams silver oxide, and if I plug that in my calculator, I get 82.5 grams, and that looks like that's the appropriate number of sig figs here. So whenever you're doing stoichiometry with gases, you're just going to use PV equals nRT at some point to find moles. And you might use it at the beginning, or you might use it at the end of the problem, but just keep in mind that this is there, and that equation is always there for you on your equation sheet. All right.